So now we're going to be starting 4.3. We're going to talk about drawing angles, determining which quadrant they lie in, coterminal and reference angles, and also finding trig functions of any angle. It's going to have some overlap with last time, but it's also going to have some new stuff. Now, some of this I had in your notes, and some of it I didn't. So this is one that's not in your notes. You probably know this, but if you don't know it, you can add it to it, okay? So when I draw an angle, what I'm going to do is I'm going to start with what is called the initial side. Initial means it's where it starts, and this is a positive x-axis. So right here, this is what I call the initial side. And then what I'm going to do from there is I'm going to proceed counterclockwise to make an angle until I get to what is called the terminal side, which that is where it ends. So this angle right here, it's normal to go counterclockwise like that until we get to the terminal side. And you have just created an angle. Isn't that great? Now, which way do negative angles go? If regular angles are counterclockwise, negative is counterclockwise, also known as clockwise. Okay, cool. Now notice that this is going to split, we have one rotation split into 4 regions, which we are going to call quadrants, okay? There's quadrant 1, 2, 3, 4. We use Roman numerals for them. And it goes counterclockwise as well. If we have a negative angle, it doesn't change the order. Okay? Now, have we gone over this before? Or is this new? Yeah. Okay. So it's some you've learned, but just not gone over with me. So now that's just the basics of how to draw angles. We're going to do a little bit of that, and I thought I would just start from the beginning in case you've never drawn angles before, but I think you have. There's 2 types of angles that we need to know about. One is called a reference angle, and then the other one is called a coterminal angle. Let's start with talking about a reference angle. A reference angle is an acute angle. Who can tell me what acute means? Less than 90 degrees. Okay, so we're looking at an angle that's less than 90 degrees, and it's going to be made with the terminal side and the x-axis. So let me give you an example. Let's say I want to draw an angle here, and it's that angle. If I'm going to refer to that angle's reference angle, what I'm going to do is I'm going to highlight the terminal side and the x-axis. And I can see that that purple angle will be its reference angle because it's an acute angle, it's less than 90 degrees, and it's formed with the terminal side and the x-axis. Okay? And we're going to use reference angles with figuring out SOHCAHTOA because notice in the 30, 60, 90, 45, 45, 90, those are all acute triangles. It's less than 90, or they're all right triangles, but the other angles are less than 90. So I couldn't be able to use an angle that was bigger than 90. I'd have to use its reference angle. Let me show you one more example here. What if my angle went like this? How would I get that reference angle? Well, same kind of approach here. We're going to highlight the terminal side and the x-axis. So this angle right here would be the reference angle. Go back to this one and just label. This would be the blue's reference angle. And the way we're going to find it is going to depend, like on this one, these angles add up to 180. So I could just do 180 minus the blue angle, and it would give me the purple angle. Or on this one full rotation is 360. This almost went 360, but if I did 360 minus the purple angle, it'd give me the green angle. Okay? Now, our next type of special angle we're going to talk about is called a coterminal angle. Let's highlight some things here with that. Coterminal means that they share the terminal side. However, they get to that terminal side using a different route, if that makes sense. So let's pretend I was like, you know what, guys, you're a good class. I'm going to take you out to get Slurpees at 7-Eleven. Where's the closest 7-Eleven? Where do you guys point? Isn't it down that way? Are you going up 56? Oh, there's a new one? Oh. I was like going down 41st over to 64th. There's also one on 35th. There's another one down that way. Okay, so I'm like, hey guys, let's go there. What would be the easiest way to get there? Up 56. Now, what if I said, here's the rule. You have to take a different route. So let's say Griffin says, well, I want to take 56. And then Parker's like, well, I want to go. Well, I say, well, you can't take 56. Could you still find a different way to get there? What would you do? Go a different route, okay? So the idea here is we want to end at the same place. We all want to end at 7-Eleven, but we want to get there a different route. Let me show you an example here. Let's say this is my angle right here. Now this is my terminal side right here. You can't see when I'm hovering like that. This is my terminal side. Now, how could I get another angle to land on that angle but not draw the exact same angle? Well, one option is I could just go around one time and then land on it. Do you see how I landed on the same angle but I went a different route? What would be another option? How else could I get to that same angle but a different route? Yeah, instead of going counterclockwise, we'll just go clockwise. And I could just add on rotations, and those are all coterminal angles. They land in the same spot, but they had a different way of getting there, okay? Okay, cool. Now, I think the rest of these are in your notes. So this says, find and draw a positive angle and a negative angle that are coterminal with the given angle. I'm going to help you on A, it's 30 degrees, okay? When I say I'm going to do it, I mean I'm going to have Gabby help us out with it. Gabby, how would I draw a 30-degree angle? Gabby, how would I draw a 30-degree angle? Which quadrant would that land in? Yeah. How far into it? Like if this is 0, I don't know if we talked about splitting up this angle, but it's kind of intuitive. What is one full rotation? That's 360. So then half a rotation is 180. What's half of that? 90. And then what's all over here? That's 270. So now it's going to be in quadrant 1 if it's between 0 and 90. Gabby, about how far into that quadrant are we going? Yeah, a little less than half because it's 30 degrees, right? So I don't want to go more than, like half would be 45. So it looks something like that, right? Now, I want to come up with a positive and a negative angle that are coterminal. I'm going to draw this just so we're on the same page. But a positive would mean I'd have to go around once and then get 30 more. How would we figure out the length or the measure of that angle? Alright, so I'm just going to take 30 and add 360, and that gives me 390. So 390 is a positive coterminal angle to 30 degrees. Well, now, how would I get a negative angle? Let's draw it first. It's easier to think of it drawing first. So in that case, instead of going counterclockwise, we would go clockwise and land on it. Now, is that green angle one full rotation? How short is it of a rotation? So what I'm going to do is take my 30-degree angle and now subtract 360, which gives me a negative 330. And what I have just made is a positive and negative coterminal angle. Have we talked about coterminal before? I believe this is our first time, right? All right, cool. Let's go to the next angle. How is this next angle different? It's negative, which means what? How are negative angles different? They go clockwise. So my setup is going to be a little bit different now because this is still 0, but I'm going to rotate clockwise. I'm going to label it a little bit different. That would be negative 90. This would be negative 180 degrees. This would be negative 270. And that would take me to negative 360. So Amber, if I'm graphing negative 150, where is that going to land? Keeping in mind that our quadrants don't change with negatives. It's still 1, 2, 3, 4. Good. How'd you know that? There we go. So I'm going to go past 90. And how much more past 90 do we go? Yeah, we go 60 degrees. So that's just going to leave 30 degrees like this. So this would be negative 150 degrees. Now, it wants a positive and a negative coterminal angle. We're going to do basically the same thing we did on A. All right? So if I add 360, what that means is we're going to be going from the counterclockwise approach. It would be like that. That would be if I did negative 150 plus 360. Anyone know what that is off the top of their head? That's what I was thinking too. That sounds good. So I could get there by doing 360 plus that angle. Now, if I'm trying to get the negative coterminal angle, it's already negative. We're going to do the same thing. We're going to have to subtract 360. What that would do is that's going to have us go around once clockwise and then go 150, like that. So that'd be negative 150 minus 360, which is going to be negative 510. Does that sound right? Okay, what I want you to do, let's pause for 30 seconds. I want you to explain to your neighbor what we just did. Without just saying that. Explain it using words. Go. All right, we're going to go to Austin. Austin, what does it mean if angles are coterminal? Yeah, they're sharing the terminal. Now, guys, what did we do in both cases to get a coterminal? We added or subtracted what? 360, which is a full rotation. Now, when we get over to C, what's different about C? We're in radians, right? What is a full rotation in radians? 2 pi. So here's what we're going to do. We're going to start by labeling this, kind of like what we did on the other one, but now we're going to do it in radians. So 1 full rotation is 2 pi, which means half a rotation is 1 pi, which means half of that is pi halves. And if I came down here, this would actually be 3 pi halves. Now we're going to graph 2 pi thirds radians. Now, which quadrant is that going to land in? Is that going to be in the first, the second, the third? Well, here's a question. Is 2/3 more than a half? Okay, is it more than pi? No, it's going to be somewhere between pi halves and pi. Well, if I think about pi and cutting it into thirds, this would be like 1/3, and then this would be like 2/3. Does that cut the pi into 3 pieces? So this is 1 piece, that's 2 pieces, this is 3 pieces. Well, we're just going to take how many of those pieces? If it's 2 pi thirds, we're doing 2 out of the 3. So it's going to be that angle right here. So this is 2 pi thirds. Now what we are going to do is we are going to figure out a positive and a negative coterminal angle. Before to do that, we just added a rotation and subtracted a rotation, which in degrees is 360. But for radians, what is that going to be? 2 pi. Okay, so here's what we're going to do. Let's go around once, and then go 2 pi thirds. So that would be 2 pi thirds plus 2 pi. Now this is going to go back to quarter 2. We're trying to add fractions. What's the rule with adding fractions? We need a common denominator. What is the denominator of 2 pi? 1. What do I want that to be? Can I change that to 3? Sure, as long as what? There you go. You guys are so smart. So that would be times by 3 here and here. So what that's turned into is this is 2 pi thirds plus 6 pi thirds. Now do we have a common denominator? Great, add those together. What's 2 pi? 2 pi plus 6 pi. So this would be 8 pi thirds. That would be this purple angle here that goes around a rotation and then goes 2 pi thirds. So same concept as adding 360 or subtracting 360. We just have to deal with fractions, okay? Now I'm kind of running out of room. Let me come down here. We need to figure out a negative coterminal angle. Let's do that in a different color. Let's do that here in red. That would be going clockwise and landing here. So we land in the same spot, except this time we're going clockwise. So now instead of taking 2 pi thirds and adding 2 pi, what are we going to do? Subtract. And it's going to be the same process. I'm going to take 2 pi thirds, and we're going to subtract 2 pi, which we're going to have the same problem. It needs to be in terms of thirds. So I'm going to times that by 3. So that's going to be 2 pi thirds minus 6 pi thirds. And as you guys get better at this, you'll be able to figure out what 2 pi is without having to do all these steps. But what is 2 pi thirds minus 6 pi thirds? Well, what's 2 minus 6? Negative 4. So this is negative 4 pi thirds. That would be your negative coterminal angle. All right, so what we've done right there, guys, is coterminal means you land in the same spot. You just add 360 or subtract 360 for degrees, or if you're in radians, you add 2 pi, subtract 2 pi. Does anyone have questions on any of those? Go once, go twice. Let's keep on rolling here. Okay, let's read this. Let theta be an acute angle in standard position whose terminal side contains a point 5,3. Find the 6 trig functions of theta. So this is kind of like the example we did before, but it's going to be on the coordinate plane. So how do I get to the point 5,3? Well, if this is a point 0, 0, then I just go to the right 5, 1, 2, 3, 4, 5. And then I go up 3, 1, 2, 3. And that will make a right triangle. Now, what's missing on this triangle? Edgar, which side don't we know? How do we figure it out? We kind of did an example like this on the last one, where I have 2 sides of the right triangle. So what theorem is there that lets us find missing sides in right triangles? Awesome. In this case, what are we trying to solve for? Which letter? C. Okay, cool. So let's plug it in. What would you say? We can let it be either of them, right? How would you write this out, Edgar? All right, that's 25 plus 9. So that's 34. So we'll call that the square root of 34. Alright, now we want, good job Edgar, we want to find SOHCAHTOA, CHOSHA, tau of that. Before we do that, Anthony, how would you label our sides here, opposite, adjacent, and hypotenuse? Okay, cool. We've had a lot of practice with this. So now we're going to do sine, cosine, tangent. Cosecant, secant, cotangent. Hopefully you're getting better at that. Let me give you about 30 seconds before I call on 6 of you. Alright, so we're going to start. James gets sine, Hashira gets cosine, Chloe gets tangent, Isabel cosecant, Christian secant, and Leva cotangent. Give you a little bit longer, make sure you got those down. Alright, James, start us off. Sine. Awesome. Hashira, cosine. Great. And then Chloe, let's do tangent.
3/5.
Awesome. Okay, that's our normal trig ratios. Let's go to the reciprocal trig ratios. We're starting off with Isabel with cosecant.
Square root of 34/3.
Awesome. Christian, secant.
Square root of 34/5.
And then Leva. You guys are so good. Is this making sense? You okay with this? It's relating to what we did in the last section, just putting it on the coordinate plane, okay? And we're going to keep building off of this. Let's keep on rolling here. Now, how is this one going to be different? This was a 0.53. What if we change it and we go -5,3? What's that going to change? Well, let's go and let's look at it. So I'm going to go -5, so that's -1, 2, 3, 4, 5, and then go up 1, 2, 3. So if this is a point -5,3, let's draw our triangle here. So what I know here is that this length is -5 and this height is 3. Hey, what will the hypotenuse still be? Will that change? If I do a squared plus b squared, will it still give me the same c squared, square root of 34? Does that negative do anything in that case? No, how come? What's the first thing you do with it in the Pythagorean theorem lesson? You square it, and what happens when you square a negative? It comes a positive. So this is still square root of 34. So when I go through and I do SOHCAHTOA, CHOSHA, cow, I'm still going to have the same opposite side, the same adjacent side, and the same hypotenuse. But what will be different and what will be the same? Let me let you, with your group, maybe before you start figuring it out, try to think what's going to change here and what's going to stay the same. And then try to find SOHCAHTOA, CHOSHA, cow.